Hi, welcome to this tutorial on using the binomial expansion formula for expanding expressions like this, square roots of functions, or like cube roots or fourth roots, etc. Here I've got the square root of 1 minus 2x. And also for using the binomial expansion when you've got fractional expressions, something like this, 3 over 2 minus x. So how do we do these? Well, for the first one, when we have the square root of 1 minus 2x, or whatever root you've got, you need to express this as a power. And we can do this as 1 minus 2x to the power a half. If it were the cube root, it would be to the power a third, and so on. So I've got this now in this particular format. And you can see that the a corresponds to minus 2x and the n is now a half. We call this a rational power. So, using the formula, we can see that what we get is that this becomes identical to 1 plus n times a. So plus n in this particular example is a half times a, and a is minus 2x. And then we have plus n times n minus 1 over 2 factorial times a squared. So that's going to be plus n, which we know is a half. Then it's n minus 1, so we take 1 away from the power, so we get minus a half. And then we've got times a squared, so we've got minus 2x for a, and then we square all of it, so make sure you put that in brackets. And then it's all divided by 2 factorial, all over 2 factorial. 2 factorial is 2 times 1. Now, I must admit at this point, I never like writing this particular style. What I prefer to do is find a space in the bottom line here where I can write 2 factorial, and here it is here. It gives exactly the same answer, so instead of writing 2 factorial I would put 2 times 1 here. Alright, I think it really does simplify the calculation, so what I'm going to do is take out that 2 factorial, and I'll show you how it works in the next term as well. If we go plus, then we've got n minus 1, n minus 2, so we've got the power, half. Subtract 1 from that, and you get minus a half, and then subtract another 1 from the minus a half, and you get minus 1 and a half, minus 3 over 2. We've got a cubed, a being minus 2x, so minus 2x all cubed, and then it'd be all over 3 factorial. But again, 3 factorial, I wouldn't really write there. What I would do is find a space on the bottom line, here it is here, and I would write 3 times 2 times 1. But it's up to you whether you decide to do that or not. As I say, I just find that it makes the working out a lot simpler. Don't forget to put plus and so on the end, okay? So, all we need to do now is just tidy this up, and if we tidy this up, what have we got? Well, we've got that this is identical to the 1, and here we've got the 2 2's cancel, so that can go there, and we've got a minus 1, and so we've got minus x. Okay, so we'll pop that in there, minus x. And for this one here, we can do some more cancelling. That 2 and that 2 goes out with this repeated negative 2 here, minus 1 times. Alright, so what we have got is we've got minus 1x all squared, which is plus x squared, times this minus 1 on the top is going to be minus overall. So we're going to have minus x squared over this 2 here, and that gives us that term. Now we come on to this term, and I can see I've got minus 2 times minus 2 times minus 2 repeatedly. So I can cancel all of those 2's out there with this minus 2 here, which is repeated. So we end up with minus 1x all cubed, so that's going to be a minus x cubed. I can also see, by the way, that this 3 here cancels out with that minus 3, goes in minus 1 times. So you can see how the cancelling helps. Okay, well, if you work this out, what you get is a minus, and you've got x cubed all over just simply this 2. And notice the signs, by the way. You'll notice that they keep going minus, 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 so expect the next term to be a minus. You'll always find in binomial expansions you'll either get it going in one sign, like all minuses in this case, or all pluses, or it'll oscillate plus minus, or maybe minus plus, and so on. So we've got that as our final expansion. Now what about this one down here, 3 over 2 minus x? How are we going to do this one? So what we've got to do is think of this as 3 times 1 over 2 minus x, and if we bring the 2 minus x up to the top, we end up with 3 multiplied by 2 minus x to the power minus 1. Now you'll notice that in this example we haven't got a 1 here like we should have in the formula. We've got our 2. So we've got to get rid of this 2, and the way we do this is to, let's just put a square bracket like this. We pull out whatever number we've got here out the front of a bracket. So in this case we pull the 2 out and we write a 1 there. So you have 2 times 1 is that 2. Now because I pulled the 2 out, when I come to this term I need to write minus x over 2. So that when I multiply the 2 with minus x over 2, we end up with minus x. And all of this is to the power minus 1. And then what I can do next is to simply just write the 3 down. Now when you've got two things being multiplied together all to this power, then it's the same as each one of them being multiplied to the power. So in this case 2 to the power minus 1. And then we've also got 1 minus x over 2 to the power minus 1. Now what is 2 to the minus 1? Well, that's 1 over 2, or half. So 3 times a half is 3 over 2. Try and write 3 over 2 rather than 1 and a half. Okay, it's easier to work with. And then what we've got to do now is just expand this, because we've got this in the right format. We've got it in the form 1 plus a to the power n. We've got our 1, a is minus x over 2, and the power n is minus 1. Okay, so we'll just put a big square bracket there, and we'll expand this in the usual way, so it'll be 1 plus n times a. So 1 plus the power n minus 1 times a, which is minus x over 2. So put that in there. Plus, and then we've got n, which is minus 1, and then we've got n minus 1 again, so we take 1 away from the power, so that means we get minus 2. And then we have the a value, which is minus x over 2. That is now squared. And this is all divided by 2 factorial. But again, you don't have to write this. I prefer to write 2 factorial as 2 times 1 and find a space on the bottom line here. And there it is there. I can put it in there as 2 times 1. It will give me exactly the same result. So I'll just take that out. Okay, and we could carry this on for another term or so, whatever they ask in the question, but we'll just stop this here. But don't forget to write plus and so on. So all we need to do now is just expand this out. Okay, in fact what I'll do is we'll just tidy up the terms inside the bracket first of all. So we'll keep our square bracket there. We've got the 1, and here we've got plus x over 2. or a half x. And here we could cancel, if you like, we could cancel that 2 there with the minus 2, goes minus 1 times. And what we've got is a plus term here, and we've got 2 minuses here, that's plus, so overall we've got plus, so we could expect this to go plus 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 all the way along. We've got x squared, and don't forget we've got a 2 here that's squared, so that's 4, so we're going to have x squared over 4. And it will go plus and so on. So all we need to do now is just expand this out, and we end up with 3 over 2 plus 3x over 4, and then plus 3x squared over 8, and so on. Okay, well, I hope you've been able to follow my reasoning and that you could use these ideas to expand anything like these kind of expressions. Okay, well that brings us now to the end of this tutorial.